Hello everyone, Mr. Fawcett here, and we are back with another Algebra 1 lesson. Today we're going to talk about graphing lines, and specifically graphing lines when we are given the slope-intercept form of their equation. So before we get into any sort of discussions, I want to see what you know from a pre-algebra class. So take a look at 1 and 2. Number 1 says circle and name as many parts of the equation below as you can. So the equation y equals 2/3 x plus 2. Number 2 then says graph the equation on the coordinate plane to the right. So try to answer both of those questions and then join us back for a discussion. All right, so this equation, we should be able to identify a couple different parts of it. First one would be that 2/3. That is going to be the slope of our line, while 2 is going to be the y-intercept. And again, this goes back to slope-intercept form, which would be y equals mx plus b. We'll go a little bit more into detail about what that is in the next page or two, but I think for most of you, you probably could have identified the slope and the y-intercept from a previous class. So what we need to do is plot 2 points so that we can connect them and draw a line through them. So I'm going to plot my y-intercept first. That's at +2. And from here on out, we are going to write down the coordinates whenever we plot a point. So this point is 0, 2. Now remember, our x-coordinate comes first, our y-coordinate comes second. And we have our x-axis is the horizontal, our y-axis is the vertical. So when I start at the origin, because that's where you start when you think about plotting points, I didn't move in the positive x direction, and I didn't move in the negative x direction. So that's why my x value is 0. I did move up 2 in the y direction, though. So my coordinates are 0, 2. Now, if you ever forget which coordinate comes first, whether it's x or y, just think about alphabetical order, right? X comes before y in the alphabet, so it comes first with our set of coordinates. Now we have to come up with another point. Now, there's a couple different ways we can do this. My guess is that you would have counted the blocks. Maybe you've heard of rise over run. That's the terminology that a lot of teachers use when we're talking about slope. However, I don't think it's the best terminology to use. So from this point forward, we're not going to think of slope as rise over run. We're going to think of slope as change in y over change in x. This triangle here is also called a delta. Same thing down here. But what it means is change in. So let me write that in words as well. So what this really means is change in y over change in x. And again, I think that's just it's a better descriptor than saying rise over run, because rise doesn't tell you whether you're talking about x values or y values. Change in y does tell you what values we're talking about. So the slope right here, right, is 2/3. So +2 is our change in y. So if we start from this point, we can travel up 2, because that's our change in y is +2. And our change in x is +3, so we can move over 3 to the right. And this would be our new point. Again, we are going to label that with the coordinates. Those coordinates are 3, 4. And then we can draw a line that goes through the 2 points. Now, a lot of times you'll see students mark 3, 4, 5, 6 points before they draw their line. That's not wrong, it's just inefficient, because 2 points works just as well as 3, 4, 5, 6, or any other amount of points when you're trying to draw a line. You only need 2 points to draw a line between them. So you can find others, it's just not necessary. Okay, let's look at another example down below. Same idea. You're going to try to identify, in this case, the slope and the y-intercept, and then go ahead and graph it. Okay, so I think we can certainly pick out the slope here. That's going to be our -2. Our y-intercept, now you may say, well, there is no y-intercept. Well, there is, right? It's just not written because it's 0. But I can add 0 onto the equation. It's not going to change the value of the equation. It's not going to make it unbalanced. So y-intercept here is 0. I'm going to label that right away. And that point is just 0, 0. Now my slope, remember, slope is equal to the change in y over the change in x. Again, this means change in that little triangle, also known as delta. I don't expect you to have 100% grasp of this vocab by the end of the lesson, but we're going to keep using this as the year progresses. You're going to use it next year in geometry. You're going to use it the following year in Algebra 2, all the way up until, you may take calculus in high school. And we're still going to refer, with my calculus students, I still refer to slope as change in y over change in x. So our slope ends up being -2. Now, you may say, well, is that -2 the change in y, or is it the change in x? Because we don't have a fraction. Well, we can create a fraction, right? We can put any number over 1 without changing the value. So -2 is our change in y. So we're going to travel down 2. Let me do this on the other side because I'm going to go to the right next. So -2 is our change in y. And then I go over 1 because that's my change in x. I'm going to, of course, label this point. It is at 1, -2. And then I'm going to draw my line through the points. And that would be the equation of this line. Okay, let's move on to a couple of examples where you can try to identify the correct line. Make this a little bit smaller. I don't think I can fit all the choices on there, but I can certainly fit the first 3. So you're given an equation, and you need to identify which graph represents that equation. So pause the video, take a couple minutes, and see if you can narrow down your choices. Okay, so for number 1, we're going to identify the slope and the y-intercept. Right? We know our slope is -2. And our y-intercept is +5. Now, you don't have to graph this, right, on your own. You just have to identify which graph is correct. So let's do an easy process of elimination. Which graphs do not have +5 as their y-intercept? Well, we can eliminate C, right, that y-intercept, and I guess I shouldn't have done that in blue. That y-intercept is somewhere between 2 and 4, so it's certainly not going to be 5. And let's take a quick look at D. We can also see that D does not have a y-intercept of 5. That y-intercept is 0. So we can eliminate C and D, and we need to choose between A and B because both of those have a y-intercept of 5. Now we need to figure out the slope, right? And because these choices, right, A and B, have different slopes, one is positive, one is negative, well, if we can just choose the one with the negative slope, we don't really have to go and make sure that it is a slope of -2, because by process of elimination, we know it has to be. So again, if you're confused as to what's a positive versus a negative slope, let me just give you a quick little visual to help you with that. For a positive slope, as we think about moving from left to right, you can think about someone walking uphill. All right, that's going to be a positive slope. For a negative slope, again, moving left to right, it's going to be like someone is walking downhill. So if you just have to identify between positive and negative, this is a very easy way to do that. And we have a slope of -2, and B is the one that has that negative slope. Again, you can think about the guy walking downhill. Let's look at number 2. Y-intercept is -2. So let's go ahead and rule out the ones that don't have slope or don't have y-intercepts of -2. A and B look good. Both those y-intercepts are -2. C has an intercept, the y-intercept of +2. Oops, let's move that back. So we can eliminate C. And then D also has a y-intercept that looks like it's somewhere up here, somewhere like 7 or 8. So we can eliminate D as well. So we need to, again, choose between A and B. I'm going to clear everything when I go back up here. So we see that our slope is +1/4. Again, we have two graphs, one with a negative, one with a positive slope. And the positive slope is B in this case, right? You can see that if we think about it, the guy is walking uphill, so that is going to be the positive slope. Okay, so a little bit easier because you didn't have to actually sketch your own graph. You could use a process of elimination to figure out which one was correct. Let's go look at examples where we actually have to sketch our own graph, though. And they're going to be a little bit different from what we did above. I think before that, though, we are going to quick touch on slope-intercept form. Just make sure we have it in a single spot in our notes. Slope-intercept form, y equals mx plus b. Remember that m is the slope, and the b is our y-intercept. The x and the y are just going to stay, right? Those are going to stay x's and y's. So if I just had a couple of examples, I could have y equals 1/2 x minus 12. I could have y equals -3x plus 4. Right? So the x's and the y's stay because those are going to represent the different points on the line, whereas the slope and the y-intercept, those are staying the same. Right? So we need actual numbers for those because those are not going to change when we have a single line. Right? The slope for a line is always the same. The y-intercept stays the same. It's the x's and the y's that are changing because we have a bunch of different points on that line. Let's look at 2 examples of graphing, and then we will call it a video. So it says graph the equation below, y equals 3x minus 5. Now, at first glance, this may seem like one of the questions from above, where we would want to plot the y-intercept and then use the change in y over change in x to find another point. But if you take a look at the graph, you'll notice that the graph looks a little different, right? The tick marks are marked off by 5, not by 1s. So I'm not going to go any further than that, but that may pose a problem for you when you go ahead and try to graph in the method that we used at the beginning of this video. So let's talk about parts A and B. You're going to pause the video and try to graph this on your own. And if you run into a problem, that's okay. We're going to discuss the solution to that. But I want to give you a chance to try to figure out how to graph it on your own first. Again, when you run into that problem of can I count the change in y and the change in x to find the new point, think about if there is a possible solution to that. Is there another way I could graph other than just counting, the change in y over the change in x? Okay, so the first step, plotting the y-intercept is still fairly straightforward, right? Our y-intercept is -5, and I can certainly plot that on my graph. I am going to label this point as 0, -5. Again, I just want you to get in the habit of that moving forward. It lets me, or whoever your teacher is, know that your plot, you know exactly what that point is. Now we think about the slope, right? The slope is 3, or 3 over 1, but can I really just count up 3 and over 1 and know where my new point's supposed to be, right? Because I don't have the tick marks that were apparent on the first 2 graphs for this lesson, right? If I count up 3, I can't count up 1, 2, 3, because then I've really counted up 15, right? This would be plus 15. I need to only count up 3, but there's no tick marks for me to do that. So I need to have another method that I can use to figure out my second point. Now, it's not a big deal. There is a very pretty straightforward solution. I'm going to start with my original equation, so y equals 3x minus 5. And what I'm going to do is I'm going to choose another value of x. Okay, so I'm going to choose x equals 5. So I'm going to say when at x equals 5, now let's figure out what my y value is. So y is equal to 3. I said x was equal to 5, so I'm going to substitute in that 5. So I get y equals 3 times 5 minus 5. I get y is equal to 15 minus 5, and I get y is equal to 10. So my new point is at 5, because I said x was equal to 5, comma 10. That's my y value. So I can go ahead and plot this point at 5, comma 10. And then I could go ahead and sketch. Now you may say, Mr. Fawcett, that point, fell right on one of the corners of the boxes, right? What if my point doesn't fall on one of the corners? Do I just have to guess and say, I think it's between, if my point is 6, do I just put it between 5 and 10? Well, the short answer is yes. Let me show you another way we could have done this. I'm going to start with my original equation again. Because there's an infinite amount of numbers that I could choose for x, right? Let me choose, we'll just say, we'll say 3 for x. So at x equals 3, I get y is equal to 3 times 3 minus 5, which gives me y is equal to 9 minus 5, which gives me y is equal to 4. So my new point would be 3, comma 4. So let's go ahead and think about how to plot this. Well, it's 3 on my x-axis, right? My x-axis right here, my y, the vertical. So 3 is somewhere around here, right? That's not my point. I'm just showing you where 3 is on the x-axis. I need to go up 4, which should be just before I get to 5. Right? So you can see that this point would also be on the same line. And if I had chosen the red and the brown point, I could have still drawn that line between those two, and it would have gone through that blue point as well. You could choose, again, you can choose any number you want for x. I'm going to choose a number that's on the x-axis, right? I don't want to choose like x is equal to 50, because 50 is somewhere all the way off to the right, right? So I want to be able to plot it on my graph. But let's say I'd chosen a negative number. And again, I know you only need 2 points. I'm just running through different examples that you could have done. So we'll say at x is equal to, shall we go negative 2? So I get y is equal to 3 times negative 2 minus 5. I get y is equal to negative 6 minus 5. And I get y is equal to negative 11. So my new point is negative 2, comma negative 11. Let's go ahead and see where that falls. Negative 2 on the x-axis is somewhere right here. And I need to go down to negative 11, which is just after negative 10 on the y-axis. And you can see that this point also falls right on the line. We should actually go back up and label this red point. Forgot to do that. We get 3, comma 4. So whenever your graph is not marked off by ones or by single units, you're going to need to use this method to find your second point, right? After you've labeled your y-intercept. You can always use this method. You're just going to have to use this method if your graph is not like the first ones from this lesson. All right, so this is definitely a method you want to know, because you can be assured that on a test or a quiz or maybe a standardized test, the test writer is not always going to make it easy on you, right? They're going to make sure you want to know how to graph in many different ways, including when you just count the blocks, counting the change in y and the change in x, or choosing another x value to find a second point. Let's go ahead and do one more example using this method, and then we will wrap up this video. So you'll notice that this time the graph does look like one of the ones from the beginning of this lesson, but our equation of the line looks a little different, right? There's a decimal in there. So again, pause the video, go ahead, try to graph this on your own. Make sure you're labeling the points with the coordinates, and then join me back for a final discussion. Okay, so the y-intercept is 2.3, so I can plot that. It's going to be a little after 2, somewhere before 3. Right, so that's 0, 2.3. Now, this graph is ticked off by 1s, but our starting point, our y-intercept, is not on one of those corners of our squares, right? So it's going to make it difficult if we're trying to count, the change in y over the change in x, right? There's our slope. Because we're not starting on integer coordinates, right? We're starting at 2.3. So we're going to use the same method from above. I'm going to start off with my original equation, and I'm just going to pick a value for x to find my new point. Let's do x is equal to 4. Now, you could, of course, use a calculator to just punch this in and figure out what y equals. We'll do it by hand as well. So I get negative 3/4 times 4 plus 2.3. That gives me y is equal to negative 12 over 4 plus 2.3. Gives me y is equal to negative 3 plus 2.3, which gives me y is equal to negative 0.7. So my point is 4, that's what my x value was, comma, negative 0.7. So on my graph, I go over to 4, and I'm going to go down just before I hit negative 1, because negative 0.7 is a little bit less than negative 1. Less going down. It's a little bit before we get to negative 1. I'm going to label 4, negative 0.7. And now I could draw my line. And it would keep going here. Let's do one more point just to show you that, again, you can choose whatever x value you want. Let's choose a negative number this time. So let's go with at x is equal to, we'll go negative 3, which gives me y is equal to negative 3/4 times negative 3 plus 2.3. This gives me y is equal to positive 9 over 4 plus 2.3. I have negative times a negative. And again, you're going to probably just want to use a calculator here because you're working with a decimal and a fraction. This is going to give me 4.55, which means my point is at negative 3, 4.55. We can go ahead and graph it. Negative 3, and then I'm going up somewhere between positive 4 and 5. And you can see that it should fall on that line. Again, if we were a perfect computer and as far as drawing lines go, all these points would be exactly on the line. And if you're using a ruler, your line will be even a little bit better than mine is. But these points, again, even if you're drawing it by freehand, they should be very, very close to that line that was drawn. Okay, so hopefully this gives you a little bit of a refresher about how to graph lines. Maybe these examples at the bottom were things you haven't looked at before. But right now, if I give you an equation in slope-intercept form, regardless of whether there's decimals, regardless of what the slope is, regardless of what the graph is, or what the coordinate plane looks like, right? Whether it's ticked off by 1s, 5s, 10s, etc., you should have the knowledge to be able to graph a line on it. All right, as always, enjoy the rest of your day, and I will look forward to seeing you next time when we talk about point-slope form.